What an enjoyable sound.
Currently, we are transmitting image.
Dog.png.
Oh yeah.
Our method of compression was to take each image, split it up into the Y, U, and V channels, and for each of those channels, break the image up into 8x8 blocks and take the 2D DCT of each of the 8x8 blocks. Here you can see we did it on the Andy Samberg video, and you can sort of see the outline of his body through each of the frames. Instead of storing the DCT of the entire image, each frame, we only store it for the very first frame, and then for the second frame and etc. we store the difference between that frame.
The DCT and difference framing allowed us to generate lossless sparsity in our compression pipeline so that we could limit lossy sparsity through downsampling and throwing away coefficients.
A lot of information over here, whereas in frame 1, because we only took the difference between the two frames, there's a lot of zeros here, which means that when we zip the file, it's going to be able to compress to a much smaller size. Then you can see in the reconstruction, we have the very first frame, then this is a visualization of the difference between the two frames, and then the actual reconstruction for all of the frames.
How many packets was it?
It was 24 packets.
We also made some improvements to the modem. We doubled the symbol rate of the AFSK modem from Lab 5 from 1200 symbols per second to 2400 symbols per second, and shifted the frequencies according to empirical tests of their interactions with the radio's frequency response. We also reduced the overhead of the AX25 layer by doubling the maximum packet size, reducing the number of flag bytes at the beginning and end, and making one long transmission instead of multiple transmissions to reduce radio turnaround time.
Well, we gotta wait for the 90 seconds to go over it before it even starts processing.
This is
How long did it transmit for?
so
So it kept everything.
49.5 seconds.
Okay.
Yeah, so,
not kept everything.
Oh, so it would have gone
yeah.
up.
So in this case, we actually downsampled too much.
All in all, our throughput increased by approximately 3.2 times over the naive APRS approach. This allowed us to transmit 18.5 kilobytes of data in 75 seconds. We also attempted to use quadrature amplitude modulation to further increase our data rate. However, it was too sensitive to timing and amplitude errors.
We actually get all 24 packets.
It's a bit like